All right, so I'm Chris Bond, and I'm the founder and CEO of ThinkBox Software, and I'm going to talk about pop-up render farms. So the idea is that in this presentation, I'm going to look a bit at the past because I think it informs the future. I'm going to try and define rendering. I'm going to keep things pretty basic. I know there's a lot of advanced people watching this, but let's start at the beginning. And I'm going to talk about what is and why you might use a render farm management tool. And then I'm going to talk about all the clouds, which is, there's a lot out there right now raining. And then we're going to make some decisions. So first I'll talk about myself. So I started in visual effects and computer graphics in the 90s. I started my own company in 97. And I worked on a number of feature films and projects from that period till about 2010. When I built my company, Frantic, we decentralized ourselves pretty early in the game, and we had offices in Winnipeg, Vancouver, Los Angeles, and Sydney, and we developed a workflow and pipeline to distribute shots and work between the physical locations so that artists would actually be populating shots and elements completely in different locations. And of course, we built render farm software. So I founded ThinkBox Software in 2010. And so I wanted to start off at the very beginning, at the early stage of what rendering is. And I found this in the dictionary, which is defining, the definition is to reproduce or represent by artistic means. And I wanted to talk about that because a lot of people ask me what a render management system is, what compute is, what the differences are. And so I thought this would be a good place. So in M&E, media entertainment, the process of rendering is to create and generate images. It's also often used to describe the process of creating a variety of different elements for computer graphics, meaning simulation, meshing, encoding, conversion, and even the process of manipulating any of the files or scenes that you're working with. For example, merging data, importing, exporting, and so on. So I personally prefer the word computing to rendering, but I'm going to use them kind of interchangeably in this presentation. So why are there render farms? So as we've heard, and I'm sure you've seen, there are certain things that can take a lot of time. Sometimes generating a beautiful image can take minutes, hours, days, or weeks. And you often have to generate many of those frames. So if you're creating content for film or television, you might have to generate a very high resolution, 24, 30, or 60 images for every second of content you want to deliver. And to give you some quick math, because I know it's hard, at 5 seconds to 35ths is 150 images. So if you imagine that you spend an hour to render a single image, it could take you many days to complete your shot. And so very early when you start working with content like this, it's clear that you need to distribute that workload. And that content, that workload that you're distributing, those computers distributing to, is often known as a render farm. So we talked about rendering, we talked about render farms, and I'm going to talk about how you might distribute those jobs across all of those computers. So traditionally, way back, you might have had an artist with 2 or 3 laptops or computers that he's working with. Well, not laptops back then, and he or she would manually launch part of their jobs on different computers. And eventually they would start scripting them and working with them. And the idea is that the system is distributing the work or workload across all of the computers that you have. So when you choose a render farm management system, you're doing so because you want to distribute the job across all those machines. They provide management and flexibility so that you can have a number of different jobs working in parallel. And of course, they allow multiple artists, editors, departments, and teams to share all of the different resources. So let me talk a bit about this for a second. So early back in the day, when people had render farm management systems shipping with particular renderers or applications, they often only supported their own. So in our case, we had examples where you would have 50 physical computers, and 25 of them would be assigned to a certain job or task, and the other 25 would be assigned to another task. And those 2 render farms would be competing. And so if you needed to switch jobs, you had to actually turn off the particular application on 25 computers and start up the other one so they could share that resource. It became very manual, and you would have users or render wranglers stay up all night and alter the farm based on the workload that had to get done. And this seemed really inflexible. So we design an advanced rendering system that could handle multiple different applications so that resource can be shared across one application. Sorry. So if we talk about a render farm management system, what else can it do? So you can also have a system that allows you to not only distribute the jobs, connect the jobs together, let you share different applications across different compute, but you can also have a system that will allow you to check to make sure that your jobs are going to render properly. That's the sanity check. Those are going to have complex dependency systems so that jobs will connect from one task to another to balance the load across of your resources, whether it's physical or virtual, to notify you, check idle time, and allow you scripting access to have a complete flexible control. So here's an example screen of a render farm management system. So, you've got jobs in one area, tasks, the slaves that you're using, and of course, graphs and other information. And we have clients who have, at any one time, 20 to 30,000 jobs, and each job might have anywhere from a dozen to hundreds of tasks. And they might have, 20,000 compute nodes. So the ability to manage all of those jobs and how they work together is what a render farm management system does. So let's talk about workflows for a second. So, I talked a bit about all the different things you might need to do to compute in the world of computer graphics. But you can see here there's a lot of different things. And how those interconnect and work together is really important. So it's not just a question of processing that information, but it's also about how you as a company or individual work through those applications. And so if you take this sum of all of these different jobs and connect them together, you call this your pipeline. And so I'll tell you that if you have two people in a room and they start doing a task, within a few days they'll have developed their own pipeline. It'll be as simple as they're sharing to a certain folder, they're distributing the work between themselves, they're passing the data, they've chose to use OBJ instead of a different format, but that's the pipeline. So what I've learned by working in this industry is that pipelines differ completely between companies. And not only between companies, between projects, and often even on the same project within the same company, they differ. And so the key to understanding render farm management and workflow is understanding those pipelines. And I'm going to get on to a little sidebar here. I'm going to talk about virtual machines and physical machines. So everything I've been talking about has been based on this history of rendering and computing on physical machines that are near to you locally. And it's all been known as bare metal, right? So nowadays, more and more people are starting to build virtual machines into their pipeline, but a lot of people just really still use those physical machines. And now, why would you want to have virtual machines? So virtual machines will give you a flexible platform. So I see companies that have a Linux or Windows ecosystem inside their environment, but they want to use tools that are on a different environment. And so changing your render farm back and forth to the bare metal is very complex. To go from a Linux render farm and have your thousands of nodes switch to Windows is fairly complex, but if you use a virtual machine, it's not as much. It also allows you to have software deployments on each machine that is different, and allows you to archive and build history of your workflow. And I think one of the most important things is that support for archival work, and I'll get to that more of that later. So let's talk about private clouds. And I'm going to segue into this for a second, just because the history of rendering in a visual effects facility was really about that private cloud resource. So let's look at how people render. So they either have a render farm, which is a dedicated compute resource. So they have a cold room with 100 machines, or they'll use the idle time, or they'll use a combination of both. So we have clients that have generated millions of frames, and they don't actually have a dedicated compute resource. They're merely using the laptops in the office of every executive, every secretary, and everybody else. And it seems crazy, but it's actually true. People utilize this private cloud across multiple physical locations, and basically everybody who uses local rendering is using this concept of a private cloud. So we understand that a local render farm, whether it's idle time or physical compute in a cold room or even offsite another company within the same resource, is kind of the private cloud. Then that'll help us understand the cloud in general. So let me talk about why it's beneficial to have a local private cloud and to render locally. So there's a number of benefits, but the first off is the data exists. And what I mean by that is that you're there, you've got a laptop, it's got information, it likely has the applications used on a daily basis. Someone's giving you a thumb drive, you've got the data. Everything exists where you are. And if you have 12 people on site doing previs somewhere, they're building information every day, and that data is there with you. And so, there's ways to work remotely, but in essence, the first advantage and a profound advantage is that the data exists where you are. And the second is security. So, the thing about rendering locally or working on film or other industries is that you can be completely disconnected. So we have clients who are air gapped between the internet and their compute resource. So you can be as secure as you want to be in a private cloud. And of course, you've got a pipeline of workflow. So everybody who is working every day has a very specific pipeline of workflow that evolves and changes from project to project. And if they're local and it's there, it's the way they work. So it might be as simple as, a script a TD has written every day that changes and evolves and is a glue between two pieces, and replicating that elsewhere can be difficult. And of course, if you have multiple locations or offices, you can share your internal idle resources during their dark time. And cost is a private cloud benefit. And this is something that is key, and if it's used consistently. So if you're going to use consistent render resource, consistent compute resource, local compute can be more cost effective. But let's talk about public clouds, because that's what I'm here to talk about. So it might sound like I'm an advocate for local rendering, but really there's some great advantages here. So a public cloud is offsite from your facility, generally owned by a third party. You can rent it per month, per hour, or per minute, which is fantastic. And it's very commonly marketed and sold by companies like Amazon, Google, Microsoft, and Rackspace. There's many other properties as well. Generally, you don't have access to the bare metal, and you're controlling the interface through a virtual machine. So you're installing and building a VM on one of these third-party environments. And of course, you can co-locate and build ones where you can actually rent the machines. So talking, again, I like to look at the history. So the growth of public cloud has really been by developers accessing and building out scalable tools like websites and SaaS models and CRM. And I'm going to get to SaaS in a second and talk about that. And it was really designed as an interface for developers and designers, or a closed interface through SaaS. And that was really the history of where we are in public cloud, and I think that's changing, which is good. So why would you use a public cloud for your pipeline? So you would want to, because it's a fairly elastic resource. And I say fairly because, of course, it's not infinite and there are constraints. But it's a fairly elastic resource in a way that your local compute is not. It can scale with you, and not just scale up, but also scale down, which I think is important, because you often have projects and needs which might shut down for a period of time, and carrying that infrastructure is difficult. There's a huge advantage to on-demand billing, and as opposed to initial CapEx, which I come up here. Purchasing $10 million worth of equipment for a project that you might not get seems kind of crazy. And there's a lot of great examples for how this is advantageous. One of the key things for a public cloud is there's no real-world build-out time. I have clients who have physically had to move buildings because they don't have the infrastructure, like the cooling, the electricity, the power to the building, to expand their current compute resource. So this is where public cloud comes into play. And of course, there's a lowered cost for infrastructure, and someone else hopefully is taking care of the systems for you. So I'm gonna stop there for a second and talk about SaaS. So what I'm here to advocate today isn't a SaaS model, and it's a little bit difficult to understand. And SaaS is software as a service. What I'm trying to advocate is this idea that you have a local compute resource in your building, in the palm of your hands, in your laptop, and you want to use that. But in addition to that local compute resource, you want to try to expand and spill over what I call, literally spilling over, taking those peak times out and taking that to a public cloud resource. And I think there's an advantage to having both. Now, SaaS can fit into this, but generally the SaaS approach, because it's been designed for building business applications are enclosed, CRM and ERP, companies like Salesforce are an example where you go into a SaaS system, you pay them a license fee, and you get access to a specific data set. And to get your data in and out of that is fairly complex. And to work the way you might want to work might be hard. So generally, these things work within a browser, they're business applications, they're mobile applications, and there's huge pros and cons. The biggest pro is they're very simple to engage and build out. The con is you have very little control of the pipeline and how it works for you, and you're giving up control. If you have assets or tools that you want to place inside that workflow or pipeline, it's complicated. There's a lack of ownership, and what I mean by that isn't like an ownership of the IP, but it's the ownership of the pipeline. So when you build a pipeline in a workflow, it's how you want to work, and you understand the intricacies of it as a company, as an individual. But if you log into a website and upload a thing and press a button, if it doesn't render, who's the one at fault, right? Is it the fault of the cloud provider, the SaaS model? If you don't get the result you want, is it your fault? Where does that lie? And I feel like it's important to understand the pipeline and the workflow, and how are you going to create the content that you need to create, and that you own that. And finally, in my opinion, and this could be different, there can be a premium cost, because if someone else is paying for the infrastructure, the licenses, the pipeline, the tool set, all the different tools that you may or may not be using, this SaaS model can be more expensive because there's going to be wrapped into a price. And if you own licenses or tools, you might be replicating that. Finally, there's multi-resident issues. So we have clients who are very concerned about uploading certain data sets. And even though it might be embargoed and closed off from another client, they want to ensure that they're not sharing a resource with a competitor, that the money that they're spending with somebody isn't financing a competitor. So you can have more control about that if you build your own. So so right now it's kind of been about the history, and let me summarize that really quickly before I go on. So the basic premise is that render farm management systems were built and designed to allow people to share their constrained resource of a few computers with a number of different artists and different software applications, and switch and manage between them. So let's talk about why this can change and how it would be good for you. So why would you want to expand and spill over to the cloud? I think it'll make your work better. You'll get your results faster. We had an adage in visual effects when I worked on shows that if you didn't see something 3 times in one day, you couldn't get the job done. And if you could see it 20 times in one day, then it was fantastic. If it was going to take you weeks before you could see something, that result was going to be really difficult to achieve. And that's because your most important resource is your talent. So whether that's you, whether it's a designer, whether it's an engineer, whether it's a visual effects supervisor or a painter, that's the most effective resource. So we have a nice little graph here, which has artist productivity on the left and the job turnaround time at the bottom. And the idea here is, if you can imagine painting using a paintbrush to paint a painting, and every time you do a brush stroke, it takes minutes before you see the result, or hours or days or weeks, there would never be a Mona Lisa, right? So if the faster the artist or the designer or the engineer can see the result, the better they work. I have another graph here, and forgive the productivity being at 200. That's a little glitch. I don't think anyone can be 200% as productive, except maybe some people I know. But the artist time is in red here, and the days of the week are across the bottom. So the premise of this is that after the weekend, as the artist comes into work, their productivity just diminishes because the local render resource is getting busier and busier and busier, and the turnaround time is increasing. So as this turnaround time increases, the artist is becoming less productive. And then they go away for a weekend, and the render farm chews through whatever people had pushed in there for the weekend. And when they come back on Monday, suddenly they're really effective again. So what does that tell you? It tells you you need to be able to scale your render resource. So what I like to show people is this graph, which is essentially the idea that you take everything, all of your peaks out of the equation, and you push those to an elastic resource like a public cloud. So you take your existing workflow and infrastructure, you continue to render on the resources that you have as your baseline work, but as soon as you need to go anywhere and do more work, you can just pop that off to a public cloud. And that'll keep people more efficient, and you'll get your results. So what we could do is we call this pop-up cloud. And the idea is that you've got your local office here in green, you've got your remote office, which you can use all of those compute resources, but you can add on demand your cloud region into one logical workflow or pipeline. How does that work? So I'm going to talk about, and again, this is fairly high level. I'm not going to actually log in here and do it. So the first thing you have to do is you have to build your software machine configurations. You have to store them. You have to design your budgets and needs. You have to synchronize your data. And then you have to control your compute instances with something like a load balancer to spin them up and down based on your needs. I'm going to go into each one of these in detail. So how do you duplicate your local work? So the first thing that I tell people is review your tasks, because I can't tell you what is best. You can't say to you, well, in your case, from outside, without knowing your workflow, that, move all your rendering to the cloud or move all your compositing to the cloud. What you have to do is review the kind of work that you do, where you're spending the most amount of time waiting for something, for some result, where you need to iterate really quickly, and where it makes sense. So you need to review your own tasks. Then you need to build a virtual machine image with the software that controls those tasks. And that can be done by your IT staff, or some render management systems provide a default installation tool like Google Deadline Cloud Wizard, support for Google, which builds a virtual machine image and environment for you on the fly. So the second thing you need to do, or the fourth thing on this list, is map your VM image to the cloud machines so that your render management system can understand the connection between the VM and the machines that you want to do. You assign your group names, and then the render management system can control the system. The group names are there so humans can interact. So here's an example of what I mean. So right here we have the hardware configurations on Google, and you can map an OS image that you've built and upload it to the system. And then you can name that to a group that you prefer. And you can also assign the cost per hour that hardware takes. So the idea here is you could take this fancy new 32-core infrastructure I heard rumors about, and build a hardware spec for that, connect that through the API to Google that we support, and assign an image that you've built. And that image can be anything, any of the software, any of the environments that you use. And then you map that to a nice little name like, Blender 32 core. And then you've got a machine configuration that the computer can then spin up. So let's talk about budget assignment. So the public cloud requires some constraints. So there is a cost to rendering in the cloud, and there's a cost to rendering locally, but it's a cost that you spend at the beginning, and it's easier to use a resource you've already spent than a resource that's charged per hour or per minute. So the best system is one that doesn't spend money if it doesn't need to. And I'll give you a simple example right here. If the jobs can't render, the machine shouldn't be attempting to render your job. So when you're working in a pop-up cloud scenario, you're building infrastructure on demand and scaling it up and down based on your requirements. And so if the jobs are spinning up and they can't actually render, they can't actually do work, you're spending money turning them on. So you need to make sure that you have dependencies, asset dependencies, for example. You need to provide a set of rules for how machines are going to get spun up on the cloud and when they're going to get shut down and how many you might want to start up. You have to be able to estimate the cost, which is a complex problem, but there's a lot of tools that we can be provided to do that. And this is not a problem that's trivial. So people say, we want to be able to estimate the cost of rendering for this entire project. And it's like, well, you can look at history, you can look at historical, you can sample your data, but really that's a really difficult problem to really solve. But you want tools that'll help you estimate what a job might cost to render, what it might cost to repeat that job, and so on. And you want to be safe when you're rendering on the cloud. And what I mean by that is this free soda effect. Okay. This free soda effect. So if you give away soda, which we did at our company, then people just use it. They drink it all the time, and you end up with soda that's like, one sip's gone, it's open 25 sodas on the table. But if you charge 25 cents, then people suddenly are much more careful about the soda, and they'll drink it and they'll value it. So when you're using the cloud, what I say is just be aware of that, and don't suddenly give your artists unlimited constraint. So here's an example of a budget assignment. So we have a region, we enable the region, and you set a budget. And this is very simplistic per hour metering, but you could set, this is a metering system inside the render management system here that would allow you to budget a per hour maximum spend. And if you look down here too, notice the asset checking, which I'll get back to you in a second. But that's what I was discussing in terms of making sure your assets are there before a job starts. So in terms of data synchronization, when you're building a pop-up cloud and you're building this infrastructure on the cloud, you want your data to be synchronized. So a data can consist of a number of items: project files, assets, models, textures, and of course the results. And if you want to render an arbitrary thing to the cloud, there's a number of approaches. The first off, you can determine in the course of a project what you might want to render and start synchronizing that data early. You can sync everything all the time. And what I mean by that is start syncing the entire project and then sync the deltas, or my favorite approach, which is sync on demand, or what I also call just in time. And so in a render management system that understands dependencies for a specific job or tasks, then you can determine an asset list, ensure that those assets are attached to the project that you want to work on, and those dependent assets will ensure that the system will not attempt to start a job. So in this case, we have a job that's been submitted, assets that are required for it. The assets are not available, so the job is starting to sync rather than spin up instances to actually render. And so when I talk about the spinning up the instances, what I'm really talking about is load balancing. So contemporary render management systems should, if they're going to support the cloud and this pop-up cloud concept, should be able to turn on and off those cloud machines as required. So obviously enabling this by hand would be completely tedious. Having them spin up or down is going to save money. And most importantly, can balance your jobs across regions and providers. So this is the one I like the most, is this concept of you've got a local infrastructure, you've got local machines, you're rendering, you need 10 more machines, 100 more machines, you need one job done faster. You use a system that will let you spin up those cloud machines on demand as you require them, hopefully just in time, ensure the data is synced, and then shut them down when it's done. And that could be done across providers. So, these providers I spoke about, like Amazon and Google and Rackspace and Azure, and be able to build out your infrastructure for the regions that are local to you that make sense. There's costs associated with storing data on different providers, of course, but I think that there's huge advantages in redundancy and cross-cloud workflows. So people have come to me and talked about security concerns. And of course, the most secure scenario is local rendering. A private cloud inside your company is the next most secure scenario. But I believe that if you control the public cloud resource and you're synchronizing your data over VPN or HTTPS, and I'm not a security expert, from what I understand though, is the transfer of the data is less concerning than the length of time the data is stored in a location. So if you take the concept of you're controlling the VM and you control the environment, you're controlling what you're processing offsite. So rather than processing everything necessarily, you're moving segments or elements rather than the entire final shot. And you can remove the data the moment you've retrieved it. So as soon as the simulation or the task or the render's done, you can pull that data back home and ensure that's secure. So I'm just going to finish this off and with some final thoughts. So my belief is that public compute can make all of you get your work done faster, that it can help you delay decisions as long as possible. And so I think that's important for filmmaking, for commercial, for anything where you want to not commit at any point. You want to actually delay dialogue or wording or anything till the very last minute. So because you can scale up and render at the last minute, it will help you delay all of those decisions. Pop-up cloud can be used to create emergency assistance if your infrastructure goes down. It creates redundancy. It ensures that if you get a additional workflow at the last minute, you get another 100 shots, the movie's gone longer, another company's having problems, you can take that overflow because you've got the infrastructure that you can scale up. And you didn't have to necessarily design it and build it in advance. It'll, as I noticed, it increases redundancy. And I think it's also the workflow of the future. There's a lot of questions about, decentralization of this work and having remote teams be able to collaborate. And I think that if you have remote teams that can work not only on their local computer or laptop, but they can also work on a cloud infrastructure that they all share, then you get the best of this decentralized workflow with exceptional talented artists that don't necessarily have to be in a physical location, which I think is a huge advantage. And finally, I think that time and materials billing is incredibly important to all of these industries. And so being able to track all of the time that you're working and all of the minutes and hours that you attach to your rendering might actually allow us to provide actual costs of rendering time, which depending on the industry and the openness of the vendors, allow us to put a price on what a result is about the compute or the render, rather than an arbitrary in advance decision of I'm going to pay $10,000 for a shot. So that's pop-up cloud. Do you have any questions? I give you all the answers you need. So yeah, so what I'm talking about is just essentially this idea of on-demand render process and looking at public cloud as if it's a rental machine you park into your facility. It just fits into your existing workflow, but it's offsite and someone else owns it. Thanks.